Hi, this is Doug Millar, K6JEY, and I'm here with Tony Long, KC6QHP. And together we're going to talk to you about building and operating a 122 gigahertz station. So it started in Australia, but not really. For years, people have made a few 122 gigahertz stations, but it was all about plumbing and klystrons or weird stuff that nobody had, unobtainium parts. And the worst part is you finish the radio and there's nobody to talk to because there's nobody there. So Tim Tuck, VK3CV, and some other guys got a silicon radar chip meant for cars at 122 gigahertz and designed a ham radio transceiver out of that chip. And it was successful, and hundreds of these are around the country. So if you decide to get on 122 gigahertz with your half a milliwatt and 10 dB noise figure, you'll find other people will want to talk to you and become very friendly because it's lonely up there in the millimeter waves. So all you have to do really, because of Tim's board, is put all the DC stuff in, the plugs, the jacks, the lights, the switches, and the microphone, and an IF radio. And that's really all you have to come up with in the project. So we're going to describe to you how to do it. All right, next step. So the thing on the right is the block diagram of the chip. The chip is about this big, about, I don't know, less than a half an inch on the side, lots of pins on it, and we don't need to know anything about it except it's got the antennas built into it. Everything's on the chip. So you need to bring the jacks for the microphone, DC input, the 144 megahertz output like an SMA connector, switches for the mode, off and on, PTT, and indicator lights. And you don't need a GPS, but you do need to get your IF radio, like a Baofeng UV6 handy talkie, and fix it so you can never transmit with it. Because the first thing you're going to do when you light the radio up is stick your thumb into the PTT and burn out the radio. You won't even hear anything, it'll be so fast. So what I did is on my UV6, I pulled out the rubber goodie that goes over the PTT switch, and no matter how you push that, you won't activate the PTT. So if you want to go disable it on the board, whatever, the Baofeng radios are cheap and they work very well. Do that, but make sure you never transmit. Okay. That's a picture of the board. Gee, that looks big, because it's not very big. It's about this big, about what, 3 inches on the side, Tony?
Yeah, something like that.
Yeah, something like that. But what you might notice is that there are lots of holes that don't have anything in it. That's where your wires go. DC, microphone, volume control, whatnot, go in the little holes. The bigger holes do other things like mount it. And I think this is a version 1 board. There's been a couple of versions, and it's been exciting because it isn't like somebody pushed out a bunch of boards and then walked away from the project. This is a live, breathing animal that's happening, and it's involving people in Germany, Britain, United States, Japan, Australia, New Zealand, pretty much everybody. It's a pretty exciting project. Okay, next. And these are the antennas. That was the hardest part of the project because the 2 antennas, receive and transmit antennas, on the chip are not in the same position. So their beams are slightly offset from each other. So you'd have to tune back and forth to the person you were talking to on transmit and receive. Somebody in Britain engineered a horn antenna with a coupler in the bottom that coordinates the 2 beams into one beam and comes out the end. This is slightly less than 1 inch in diameter, and it is a 25 dB gain antenna. We're talking about 2.8 millimeter frequency. It's an adequate antenna. It's not too sharp. You don't have to worry about pointing it too carefully. But that's the antenna for the for just using a horn antenna. And these are the feeds for dishes, and they don't look like it because they're really tiny. But WR8 is what, 0.08 inches, and that's what this is WR8, and this is what you put in front of the dish. Okay, so we have 3 levels of complexity. There's the beginner, intermediate, and advanced. The basic level is you start simple and build more as you get better. It's a full duplex mode. The IF radio is an FM receiver on 2 meters, like a Baofeng UV6R, and a horn antenna about 20 dB gain. It's easy to use, and you get 3 miles or so between stations without much trouble at all. But if you can get up where it's a little drier, like 4,000 feet or get in the desert where it's nice and dry, you get a lot more distance because water vapor and oxygen really affect that frequency pretty strongly. Intermediate level is the same thing as the beginning level, but you use the horn and a Teflon lens antenna. They're about $50. And while they're opaque at visual frequencies, they're perfectly transparent at 122 gigahertz. You probably want to add an OCXO for CW if you want, and a multi-mode 2-meter receiver. I use an Alinco DJ11 receiver. It's very good, works very well. And for that kind of narrower beam width, 10 dB more gain, you want to use a rifle scope to help point the radio. And pointing begins to be a little bit challenging. Not difficult, but you've got to pay attention to it. Stability and frequency accuracy are good enough for CW. It's more like a 2-foot dish at 10 gigahertz would be the same feel. And you begin to feel the variable effects of propagation. One day it'll be really clear and easy, loud signals. Another hour later, it'll be different, or another day it'll be different. So you start to see at that level some difference in propagation due to the sensitivity of the radio. And then the advanced level is using a dish antenna. And with that, you get a lot more gain, and the pointing is very challenging. And you get a lot more problems with propagation and propagation due to moisture, and it affects your distance. You get a lot more distance, but the times you can do that are limited by the propagation. You'll see those effects all the time. They're fairly well known. They deal with moisture and oxygen. And the rule of thumb is get above 4,000 feet or higher on a dry, cold day, and your distance will be better. But that doesn't mean you're going to only work 10 miles. You'll probably work 15 or 20. And at that frequency, that's a good distance. Okay. So homebrew ideas. When the first things came out, we started wiring. There were no radios. There was no set type of radio that said it was a 122 gigahertz radio, except the horn. So we just started making things like this one. This was my first throw at it. A Linhof tripod, which is very sturdy. A microphone from my Yaesu 51R. I put the switches on the wrong side. I wired them on the same side as the board because it was easier, but I couldn't use them. The zero power red dot finder didn't work at all, but Tony found another one from a sort of a rifle scope type that's much brighter that we'll show later. And the GPS wasn't necessary. So basically, I ash capped the whole thing and started over. But what I did keep was that there was a second version of the board which came out. The problem was it's an FM circuit, so without a limiter on the microphone circuit, the louder you talked, the weaker your signal got. So when you're getting really excited, the signal disappears. You can't aim it or anything. So the limiter was a much more tame radio and worked much better. Still, with a horn, it was 3 miles or 4 miles on an average day. Lots of fun. And Tony and I have worked each other several times. Oh, that reminds me. Don't build your radio alone. Have a buddy. Build a radio with a buddy. You know why? Because when you get done, you want to talk to somebody. And if you don't build it with somebody, nobody's going to walk up to the door and knock on it and say, hey, I got a 122 gigahertz radio. Or you're going to find, like here, we've had people drive down from San Francisco in the old days for 47 gigahertz to try and talk to somebody because I was the only other guy with a 47 gigahertz radio, 2 people in the state. So maybe plan on making 2 radios and having a building buddy. It's a lot more fun anyway. Okay. N6NB, Wayne built a box, really simple. He just got a box, regular, that type of box, and put it all in there, including the microphone. He had a little electret microphone he poked up out of the top, and used a headset microphone boom set. That's really pretty, sketchy, I said to myself, until it worked. It worked really well. 2.5 miles, no problem. Aiming was easy, talking was easy, frequency access was easy. And we used those a little bit. No tripod, nothing. But 2.5 miles, no problem. It had to be line of sight, but it was no problem. And then we get to the blue box. We'll tell you more about the blue box. But I wanted to show this without bragging, that I put my HP 1197Q 33 to 50 gigahertz mixer in front of the radio, and I got a good trace on my spectrum analyzer. Next slide. Here's the trace I got. So I used a mixer at 33 gigahertz to show me a signal at 122. And there are actually lots of mixers that'll work if your spectrum analyzer will accept an external mixer. But notice the frequency readout. 122,500.417000 megahertz, and it's accurate. I can do frequency measurement on the spectrum analyzer. I don't need a counter. Of course, it's GPS locked, and it's an HP analyzer, but still, I never in my longest day thought I would have test equipment that would work up that high. And it turns out I do, and they're not terribly expensive. Okay, next slide. Well, there's my wife, Helen KI6LQV, out in Signal Hill using the Blue Box radio. I guess we'll call it that. That uses a Linhof tripod. It isn't just a regular chintzy camera tripod. It's a Linhof used. A Baofeng UV6 anti-talkie, a rifle scope, external microphone, the same Yaesu microphone. The horn just peeks out of the box because one thing about the horn is it's pretty good on this side, on the big end, but there's a little end that goes on the board and it mounts with 4 screws. If you wiggle this thing, it won't wiggle very much, but what it does is it bends the board, and the board is not meant to be bent, and the little surface mount parts won't stay where they're supposed to be. They'll fall off to the bottom of the chassis. You'll have to find out who they were and where they went. It's not a happy day. So the horn cannot stand any flexure. So when you mount it, be careful. Let's see. Easily does 4 miles. Yep. Day in and day out. And you can't see it, but the HT was modified and it'll never transmit. Okay. So here's where Tony comes in. He worked on the intermediate level Blue Box radios, and he's done some really, really interesting things. Tony, tell us the story.
All right. So up at the top here is a radio I built about 10 years ago. It's my first 24 gigahertz radio. And that was built with what I consider sort of classic microwave radio design approaches. Lots of machining of metal, lots of fasteners, heavy, resistant to RF, just very sort of classic design.
Is there waveguide and baseball switches in it?
Yes, there is a waveguide switch and, directional couplers and plumbing and all kinds of fun stuff. Waveguide filters, So I thought, okay, we're 10 years ahead. All of the RF stuff is now pretty much on a single chip. So I don't really need all that shielding. And, it wouldn't really do much anyway. So I decided to make a radio box the easier way, which is to avoid all the metal work and make it, out of commonly available materials. So I started
what's the time constraint on it? It used to take you.
Oh yeah, this took the 24 gigahertz radio took months to build, just tons of time. This new approach using 3D printed parts and extruded aluminum pieces takes days to build at most. If you have a design, you can knock this out in a day easily. So here's the main difference: plastic versus metal, and digital manufacturing versus analog manufacturing. Those are the main things. Now, what are the benefits of digital manufacturing? Well, I can share this design with other people. If somebody else wants to 3D print, the end plate that I built, I can send the file to any country and they can print it out. And if they decide that, hey, there's some tweak that they made that makes the design better, they can send it back to me and then I can modify mine. So
I don't have a big expensive 3D printer. What do I do?
Well, you can buy a 3D printer for pretty cheap, or you can find a friend who has one.
Find a friend.
But really, you can get a decent 3D printer these days for a couple $100s, and they're not that hard to use. If you can use YouTube, you can figure out how to use a 3D printer.
All right.
All right. So pros and cons of plastic. So untreated plastic offers no shielding. Now you can get paint that will be conductive and keep the RF in or the RF out. Plastic is light. That's a good thing. If you break something, you can print a new one for pennies and zero labor time. That's the amazing part. You know, sure, metal won't break as easily, but occasionally it will, and redoing it is a pain. Some plastics don't hold tolerance as well over time, so if you're designing something like this, make sure you use the right thing. For instance, if you're 3D printing, don't use PLA because it doesn't hold up to temperatures very well, and these radios are going to sit in the back of your car or in the bed of your truck or somewhere, and they're going to melt. So make sure you use the right material. Consumer 3D printing is still not really great for high performance waveguide structures over about 5 gigahertz, and plating is still not widespread. So if you're making waveguide structures, generally speaking, 3D printing is probably not going to be the way you want to go. For some more complex shapes, it's really good, but there are trade-offs to consider. CAD tools. So anymore, I think CAD is kind of a strange term to use. Why do we call it computer-aided design when the bulk of design these days is done using a computer? It should just be design. And if you don't use a computer, maybe it's non-computer aided design. In any event, if you don't know how to use a CAD software, there's a fairly steep learning curve. None of the software out there is actually that great in terms of its user interface, because most of it is designed for professional users, people who don't mind that steep learning curve, you know, can take a 2-week class to learn it. It can be very expensive, especially for anything decent. The tool that I use that isn't super expensive is called Fusion 360. You can use it for free. It's decent. It's not wonderful, but it does have a lot of good capabilities. And there's also a ton of resources out there in terms of videos and tips. You can search for just about anything, and there will be somebody who's done it and put a video up on YouTube. So that's really, really useful if you're learning CAD. Laser cutting and engraving is really, really great for front panels, and I'll show you that in the next chart. If you have access to a laser cutter or engraver, fantastic. If you don't, there are online sources that you can send a file to them, and they will send back something that's, you know, perfect, basically.
So really, if I liked your front panel on the next chart and I wanted to do the same thing, you could email me the design. I could send it to a company, and out would come the front panel. Yep. I'd never have touched a drill or a decal.
Exactly. And because it's engraved, it won't come off. And it looks good.
Yeah. Well, show it.
Well, let me do the last part here on 3D printers. So if you're new to fabricating parts, 3D printers are cheaper than a milling machine, and they're constantly improving. I have both a milling machine and a 3D printer. I use them both, but the 3D printer, if you're totally new to fabrication, I would suggest starting with that. They're a lot cheaper. There's tooling for a milling machine that costs more than a whole 3D printer. So check out what's available. All right, front panel example. So this is the user end of the blue box radio. And it took about 20 minutes to design this, and about 5 minutes to fabricate. Go into a simple design tool, put where you want the labels, then make the outline of all the holes, draw it up, send it to the laser, and 5 minutes later it's done. Unfortunately, so the great thing here is the engraving for the labels and the cutting of the holes are all done on the same machine in one job. Unfortunately, a decent consumer laser is about $5,000 and up. There are some cheaper options that are available now that use a laser diode, but they don't work well on acrylic plastics. And so if acrylic plastic is something that you want to use, carbon dioxide laser is still the recommended tool. Now, if you are fine making this out of wood, you can cut through 1/8" Baltic birch plywood really easily. That can also engrave, and you can do that with one of the $800 to $1,000 lasers that you can get on Amazon.
Are there places you can send it to, the design to get it done?
Absolutely. The last thing here, you can send your order out and have it made, just like you can do with printed circuit boards now. All these things are easy. So, yep.
I was going to say, I'm sorry to interject it, but if you're watching this and you're interested in the project, we're really giving you kind of a thumbnail of what the project is like. If you want good details, then go to the 122G project at groups.io. And that's where everybody talks back and forth, and where all the files are, and where all the schematics are, and all the history. It's 122G as in golf project, all one word, on groups IO. Okay, sorry to.
Sure. Okay, I'm going to skip ahead here to metal panels. So not used on this radio, but this is a different project that I did. This is a front panel that I made from 6061 aluminum, pretty common alloy, and I used a water jet that I have access to. The water jet's amazing, and if you have access to one, they're incredible. They can do everything that a laser can do, but with almost any material. Again, you can get this service online too. You can get parts laser cut, and they're not terribly expensive. If you want a really nice looking radio, this is a great option. And one thing I would recommend before you go using these, more expensive surfaces, you could 3D print this panel and do a test fit before you send it out for production. So 3D printer is your friend. Okay, so as I mentioned earlier, I use Fusion 360 for CAD. These are some of the parts that I've built and designed using Fusion 360 and some of the parts that you see in the Blue Box radio. So you can create some really elaborate stuff. And, it has some limitations, right? Like if you want to export something to use on a laser cutter or a water jet, you have to pay. It stinks, but that's what it is. There are also CAM capabilities, computer-aided manufacturing. So if you want to go generate G code for a milling machine, it will do that as well. Okay, here's my printing setup. So I have 3 3D printers. 2 of them are what are called fused deposition modeling printers. That's where you take a spool of filament, melt it, and deposit it and add on top of that. I also have a resin printer, which is good for really, really detailed, smaller stuff. It's a kind of a pain to use because it uses chemicals. One of the things I really tell people when they get into 3D printing is make sure you have a safe place to operate your printers. Printers operate with heat, and if there's a fault, they can start fires. I burned down my garage, not because of 3D printing, but another case. And so I'm a little overprotective now with my stuff. So I built this cabinet. The cabinet itself cost more than my 3D printer, but it's made out of fire retardant materials. It's got the ability to keep the heat inside, which is really good for 3D printing. It also has a ventilation system for some of those plastics that produce fumes that you don't want to breathe. It has acoustic insulation and 2 really interesting fire safety features. The first is called a safety sensor, and you can get these at Home Depot. It basically detects smoke and will shut down whatever's connected to it. Usually they're for microwave ovens, but works great for a 3D printer. And finally, this thing called the Blaze Cut automatic fire extinguisher. You can't see it in this picture, but there's a hose that snakes around the inside ceiling of this cabinet, and it's filled with a pressurized fire retardant. Once the flames hit that and melt it, it explodes open and releases this chemical that doesn't leave a residue. It just puts out the fire instantly. Really, really good stuff. Okay, for the antenna calibration fixture, I wanted to figure out, okay, we've got this dielectric lens that Doug was talking about. How do we figure out how far away to place it from the horn? So I built this little fixture. Again, this is using 3D printed parts and aluminum extrusions, and it allows you to get very precision accuracy on whatever you're doing.
Did you find the distance of the lens from the horn was critical, or was it fairly easy?
It was pretty easy to find, yeah. And it matched up with some other measured results that another ham posted.
Yeah. You can contact us if you're interested in finding out where the lenses are from. There's a company that makes a whole variety of Teflon lenses.
Yep. All right, we're getting short on time here. Let's see. So this is the Blue Box with the optional lens accessory. So you can remove this lens if you want a more compact design. And I actually built a little Azel mount for this thing that works really well. It's a little bit different than what you see here in this picture. This is sort of version 1 that, again, because I 3D printed these pieces, it was easy to just chuck them in the bin and start over again. I didn't have a whole lot of time invested. But I do have a nice little holder for my IF radio on the side. And on the other side, there's a spot for a battery as well. All right, Doug, do you want to wrap it up here?
Yeah, the conclusions. Basically, it's a DC only construction. We don't have to do any RF wiring or waveguide or anything. There's a lot of 3D possibilities. Tony, are you willing to talk to people if they email you and give
Absolutely. Yep, I'd share files or whatever. Yeah.
Yeah. So So we found that probably the best thing to do is start at the basic level and go to the intermediate level. And then if you really have some abilities or some buddies, go to the advanced level. There's another board coming out, probably my guess is March. It's a dual frequency board of 122 and 134 gigahertz, and it's a much more sophisticated radio. Now, a lot of guys have bought extra boards. So if you want to start with one of the basic run number 1 boards, you could go to Groups.io and say, does anybody have a spare board, and buy them from them. I think the original boards are about $100. The new ones are going to be more expensive, and there's a lot of people waiting for it. So don't be afraid to email Tony or I and ask questions, and certainly look on the Groups.io.
And Doug, what color is the next radio going to be?
What's up to you? Blue is good, I think.
We have to differentiate.
Green. Nice 100 green.
Green it is.
Let's do green.
All right. I think we got a couple more charts here. All right.
Work with a buddy. Zoom together if you need to. That saved everybody a lot of time. Tony and I are Zooming tonight instead of me driving over to his house or to mine. I like going to his house, but it's a ways away. Combine lab resources. If you're with a radio club, see who's got what. Can you make spectrum analyzer work or power meter or whatever? And again, coordinate on DMR if you need to. If you want to coordinate on 2 meters and you're in places where the 2 meters doesn't work, like up in Seattle, then try DMR radios, because you can go on the internet and talk no matter where they are. And then join the users group at 122 gigahertz projects. And the last thing is buddy up with somebody. Okay, we got questions and answers. Thanks very much for listening to us. Look forward to your feedback and questions. Thanks, Tony, for all your work. Great stuff. Great stuff.
All right. Thank you, Doug.
All right. Well, that's the presentation. Don't see a bunch of questions popping up, but if anybody has any, now's the time. Well, if there's no questions, tell a story. Question. Doug, do you want to answer the question of what kind of range you're getting on the more advanced setups?
I think the record with the K6ML is 134 kilometers, but that's with 2 dishes. Usually when we want to do some operating, can you hear me, Tony?
Yep, can hear you.
When we want to do some operating, we don't live terrible ways away, but maybe about a half an hour. We'll go over to the other guy's house and set the 2 radios up across the 2 driveways, or a small distance of 100 feet or so, and make sure everything's set correctly. Maybe the HT dial has moved off, or one of the switches got bumped or something, just to make sure that we're actually going to be on the air when we need to. And then from that, go, because it's only a few miles, go to the distant position and talk to each other. It's been successful every time. We have some hills here that are about 300 feet high, and then an airport. So one of the easy ways to do things is to go from the hill to the other side of the airport, which is about 3 miles or so, and you can actually almost see the person at the other end.
There's a question here of, are there certain areas in the U.S. that are higher in use of 122 gigahertz?
That are what?
Higher in use of 122 gigahertz. What areas of the U.S. are more concentration of of use of these
Well,
frequencies?
I would say us in Los Angeles. We're the only two guys, I think, well, four guys on the air because Wayne Overbeck has a set of radios. Other than that, I don't think there's any built radios. And then back east, there was a bunch of boards bought, but I don't think I haven't heard of anybody getting on the air. And K6ML and the San Francisco group has had a number of people on the air for quite a while, actually. So it's what did they sell, 300 or 400 boards the first time around? So I
think it's the usual suspects: Southern California, Northern California, and a scattering on the East Coast. Where there's microwave activity, there's probably a subset of those that are into the millimeter waves as well.
Yeah.
But it is also one of these things where people aren't very good about talking about their activities. So there very well may be people making contacts in random areas that nobody knows about because it's just not published anywhere.
I saw some from the Midwest group this last year, Ohio and Chicago. Not sure what it was, though. The night.
Okay, a request for listing emails. I don't know that I have a way of typing in the emails onto the screen, but my email is tonylong@gmail.com. That's my first name, Tony, last name LONG @gmail.com. And Doug, I don't know which one you want to give out.
I'm going to type it out here.
So, Doug, nobody else can see that besides the presenters. So,
oh, okay. So my email is from Buck Rogers. My email is Dr. Zarkov with an F 56 @yahoo.com. Oh, okay.
Thanks, Don. You got mine.
The nice thing about this project is it doesn't require a lifelong expertise in microwave engineering. It's basically a DC project and very much focused on operating and propagation and things like that. So it means that almost anybody, if all you've ever done is QRP on 40 meters, you're probably a good candidate to use the radio. Let's see.
So let me ask a question of the audience. Is anybody that's watching here interested in getting on 122 gigahertz or building a radio? All right, well, either everybody's typing all at once or nobody's typing. Okay, any final questions here? I think we'll wrap it up if there are no more.
Yeah.
All right, well, I think that will do it for this talk. Doug, thank you. And apologies for some of the technical difficulties at the beginning. Oh, James KE0VWQ is interested. Okay, good. So we got at least one person who's going to be on the air. Excellent. Don might be interested. Just other facets of the hobby. Absolutely, there are many. Yep. Okay. Well, thank you, everybody, and enjoy the rest of the conference. Oh, there's our calls, emails.
Yeah, hang on for just a little bit.
Yep. Would it be useful as a data link? Yeah, very likely. I just read about an experiment that was done in Europe at, I think, 155 gigahertz for the next 6G experiments. I think they claimed a distance of a whopping 300 meters. Of course, that was probably at, many gigabits per second of bandwidth.
I think because of the PLL, these are pretty bandwidth. The FM seems to be about as wide as it'll tolerate.
Yeah, I mean, you could do data. It wouldn't be super fast, but it would work.
Yeah, the newer board that they're going to come out with next spring is going to be directly modulated with FT8 data mode. So, well, Michelle, should we pull the plug? Yeah, I think we're off the air.
All right. I think I'm going to go QRT.